Okay, today I am going to discuss about the phenol. You know that what is the phenol? Benzene ring is attached with the OH group. Just like alcohol, you know, the alkyl group is attached with the OH group, that is the alcohols. So here we are going to discuss about the phenol, some of the properties of the phenol and some of the reaction preparations of the phenol and some of the reactions of the phenol, which are all mentioned in your syllabus. That is what I am going to discuss here. Let us discuss first about the phenol. So phenol, it is the OH group in the phenol, it is more acidic than corresponding alcohols. First things remember about the phenol is they are more acidic than corresponding alcohols. So when react with say a strong base like NaOH, so phenol form corresponding phenoxide ions. What is the phenoxide ions? So or sodium phenoxide plus H2O. So let us discuss more properties of the phenoxide ions. So you can say that this phenoxide, why it is more acidic than corresponding alcohol, because of the phenoxide ion. So these phenoxide ions can resonance structure and corresponding, there are different resonating structures for the phenoxide ions. We know that resonating structure in your previous discussion. So simply these are you can say that 4 resonating structure is there for phenoxide ions. So we can write like this: the negative charge is delocalized over this carbon and with oxygen, and simply phenoxide ions have a 4 resonating structure. That is why they are more acidic than corresponding alcohols. So, but they are not. They do not react with. They do not soluble in water, or they do not react with the weak base like sodium bicarbonate or sodium carbonate. So they do not react with the weak base. They react only with a strong base like NaOH or KOH. They form corresponding phenoxide ions. So similarly, it is also reactive with reactive metal like sodium. They also reactive with the metal like active metal or reactive metal like sodium, and also forms phenoxide ions, and corresponding hydrogen gas is released. Again here also forms sodium phenoxide ions. The second important thing about normally we are doing the reaction with the test for phenol is basically with the reaction with neutral ferric chloride solution or alcoholic ferric chloride solution, neutral or alcoholic ferric chloride solution. They form a complex and they change the color of the ferric chloride solution. For example, it is forming a six-membered complex, six-membered complex with the six-membered complex with the ferric chloride solution. It is used for the test for the phenol in the lab, and it is a violet color. Okay, violet coloration is there. So this is a test for phenol. So what are the, we have discussed about the the acidic nature of the phenol. Phenols are weak acids. They do not react with a weak base, but they react with a strong base only. Second is they react with the active metal like sodium. And third, we have discussed their formation of the violet color complex with the neutral ferric chloride solutions. Now let us discuss about the preparation of the phenols, which are mentioned in your syllabus only. Okay, so first things mentioned in your syllabus is the reaction with diazonium salt. So you know that we have already discussed enough about the diazonium salt. It is actually diazonium chloride. Okay, so diazonium chloride on hydrolysis with warming the diazonium chloride and forming the phenols. So this is the first reaction. Here N2 is released and HCl is also formed. So it first preparation of the phenol from the diazonium, how diazonium salt on warming the diazonium salt with water forming corresponding phenols. And second things mentioned in your syllabus is the reaction from the preparation from the benzene sulfonic acid on heating with the molten NaOH. On heating they form the phenols. So this is the second things mentioned in your syllabus. Okay, now next is the preparation from the cumene. So the cumene is the third preparation from the cumene. So on a reaction of the cumene with oxygen, form the cumene peroxide. So this is cumene peroxide. Okay, so cumene peroxide on hydrolysis in acidic medium, okay, form corresponding phenol and acetone. Okay, so this is third preparation which is mentioned in your syllabus. Okay, so three preparation I have discussed. One is from diazonium salt and heating the diazonium salt in water form the phenol, and the fusion of the sodium sulfonic acid with NaOH form also phenol, and cumene on the oxidation of the cumene and corresponding hydrolysis you will get the phenol. Now let us discuss about the reactions of the phenol which are mentioned in your syllabus. Reactions of phenol. So it undergo various type of the reactions, but in your, the syllabus mentioned a few of the reactions which are mostly, you can say, the electrophilic substitution reactions. So first electrophilic substitution reactions we have already discussed the electrophilic substitution reaction also in the previous lectures. So the phenol on treatment with say bromine water. Okay, so bromine water means bromine and H2O. So phenol react with the bromine water to product. The mechanism I won't discuss here the mechanism. I will discuss the mechanism in details later. So I am just here is giving only the product. So we have already discussed enough discussion about the electrophilic substitution reaction. Anyhow, you can say that with the bromine water, the phenol react with the bromine water form corresponding orthobromophenol and parabromophenol, and reaction with the bromine in CCl form, the phenol form tribromophenol. So tribromophenol. Okay, so 2,4,6 tribromophenol with the bromine in CCl form. So first reaction of the phenol with the bromine. Second reaction, Reimer-Taymer reaction. Reimer-Taymer reaction. Okay, so it is very important reactions basically for the preparation of the formulation of the phenol. Actually, it is the you can say that formulation of the phenol. Remember what is the Reimer-Taymer reaction? Reaction CHCl3 NaOH. Okay, so this is forming and followed by acidification form corresponding salicylaldehyde. Okay, the formulation of that is with the Reimer-Taymer reaction. What is the reagent? CHCl3OH, basic CHCl3, and followed by hydrolysis, acidification, resulting the corresponding substituted formaldehyde is substituted in the ortho position. This is called a Reimer-Taymer reaction. Okay, here the intermediate formed is CCl. This is a carbene. This is a carbene formation. Next is Codd's reaction or Codd's. So high pressure 7 atm and 100 degrees Celsius. Here also it form corresponding the carboxylic acid substitution. Okay, so this is second reactions which is mentioned in the syllabus. I will discuss details of the mechanism in the next video. And Third reaction is the reaction with the formation of azo compound. The reaction with the benzene diazonium salt. So benzene diazonium salt react with the phenol, forming the corresponding azo compound. Say it is, I'm writing like this. Okay, it is forming an azo coupling reactions. Say we can, this is a very colored compound. It's an important reactions of the phenol. Okay, so thank you for watching.